Our presentation this evening is going to be by Nathan. He's going to talk about Anki Robotics.
All right, thanks everybody. Thanks Wayne for letting me do this. Like I love this club, you know, as you guys probably heard, I've been coming here for a long time, so it's pretty cool to actually get to stand up in front of everybody and talk about what I do. So basically, I'm going to talk about my experiences making consumer robots, and then hopefully leave lots of time to answer questions or maybe break off after and do demos or discussions or whatever. You guys have heard I work for Anki, and they make me say this. You can probably tell by looking at me that I'm not from sales or marketing, and I really don't want the PR team to know who I am. So I don't speak for Anki. I think I'm probably going to get a lot of business details wrong if I veer into business issues or whatever. Just bear with me. And please don't get me in trouble by attributing something I say tonight as something that Anki said, because I'm just a club member talking about some interesting things that I've learned since working at Anki. Also, if you're expecting a polished presentation, sorry. Anyway, I'm going to quickly introduce myself. I think like a lot of people here, I got into robots at a pretty young age. Really, it was Isaac Asimov that did it for me. But there's also this movie I watched about 100 times. So now you know how old I am. It's not for adults. But if you haven't seen it, it's about this guy in the foreground. He's an inventor that builds these consumer robots. And they're really cool robots. They have personality, they're social, they show curiosity and emotions. Like there's this whole sequence where they go off exploring on their own and have all these interactions with people that's just really cute. And then the inventor himself is basically homeless because he doesn't make any money on his robots, which is incredibly realistic, I think, especially for an 80s movie. And I mean, it's like a whole plot point. Like this woman in the foreground is like right now trying to explain to him that he needs to hire a marketing team and charge more and find a distributor and everything. And then later on in the movie, all that happens for him, and suddenly he has to make thousands of robots. And it's a huge disaster because his prototype didn't scale to mass production. Basically, this is my life. And it's prophetic, and consumer robotics is just a tough business. But anyway, yeah, my 10-year-old self looked at this guy and said, wow, I'm going to be just like him. I'm going to sleep on a couch in a warehouse, which he does in this movie, and now I am. Unfortunately for me, I grew up in the 90s and you couldn't get a robot job yet. So I had to work for a 90s company for a while. That was their actual 90s logo, by the way.
Macromedia.
Yeah, Macromedia.
Awesome.
Yeah, long dead. But then, lucky for me, I found the Homebrew Robotics Club.
Yes.
And it was amazing. Even back then, this was like 2004 or something, like Wayne was running everything. Yep. Like camp was there. Like there are a lot of people here, but like thank goodness for Wayne keeping this thing going for as long as he has. Without this club, I wouldn't have met other people who built robots. I wouldn't have really believed that you can build robots. So as you can see in this picture, I started building robots in my free time. And next thing I knew, this guy told me he said I have to interview at Nito Robotics, this hot new startup, even though I had no relevant experience. I got the job. Yeah, and
the XV.
Yeah, the secret to getting a job, by the way, I'll tell you how to do it, is bring your robots, because nobody even looked at my resume. They were too busy, like asking questions like, how did you do this? How did you do that? Why? Like, how does it balance? Like, blah blah blah, etc. And so, I just bluffed my way in. And next thing I knew, I was working on this like really amazing product. We hadn't launched yet, and at the time there were no home robots with a laser scanner or mapping or slang.
2008, 2009.
Yeah, that's right. That was about 2008. It was an incredible time. And so Nito was way ahead of its time, still is, of course, and it was really cool to be the first company, like, I mean, to be looking at data like this at my desk and seeing like, you know, we're doing this in mass production at a major scale and learning so much so fast. One of the things that I heard at NITO, and unfortunately the guy who told me it is not here tonight, so I won't embarrass him, but he did tell me that like 80% of the effort in robotics is getting that first unit working, and then the next 80% is to get 10 units working, and then there's 80% more after that to get 100 units working, and so on. It just doesn't get easier. Every order of magnitude is more and more work. And to get this robot working in 1 million different homes, which it literally does today, was just, you know, endless work, so much more than I thought.
Pick up over a ton of debris a day.
A ton of debris a day. I'm not surprised by that statistic at all. And so, like, I had spent like 25 years just sort of like as a hobbyist reading textbooks and like building robots at home and doing all that kind of stuff. But 1 year at NITO was just like the crucible. And I learned so much. It was really exciting. And I also met these guys. Yeah. So camper.
The gruesome twosome.
That's right. These guys were our interns.
Some things will not be retold.
Yeah, they were actually the, oh God, don't say that. They're actually the brains behind a lot of the hard robotics problems too. They wrote the original SLAM algorithms and a lot of the behavior systems and all that stuff at NITO in the early days. And totally by accident, because of someone else I won't embarrass tonight, I found out that they were starting a company and it was top secret and I wasn't supposed to know about it. And so, of course, I started emailing them every month saying, hey guys, what are you doing? Do you need somebody like me? I can do anything. I'm really versatile. Just let me know if you're hiring anybody. And all I knew about them was that they were trying to build robots with personality, which was basically like my dream job. And they had no funding and they really didn't need me. But I kept bugging them until finally one of them mentioned, like, well, we actually are looking for a hardware person to help out with some of our hardware problems.
You're a software guy, though.
Well, you know, Kent knows this. I don't think they did. So, I've been a programmer my entire career, and yet today I'm director of hardware. I'll tell you how I did it. There were only 4 people at Anki, and I knew more about hardware than any of those 4 people. So that much was all it took. And so that was about almost 7 years ago now, so it's been a while. And we were just a handful of people in a little tiny office trying to figure out, like, how can we launch a robot in 1 year? And doing that is not easy, because building a robot, you know, you can build a home robot in a month. You know, a lot of us have done it, but actually, like, building an entire company, launching marketing strategy, finding a factory, signing retail agreements. There's a lot to it, and so basically, we've come a long way, and we're now making money and selling a lot of robots and working toward that goal of having a robot in every home, which was kind of how the company was founded. If you've played with our products, you're probably thinking like, well, yeah, I mean, you guys are making toys, that's a low bar, it's pretty easy to sell like millions of toys, and that's exactly right. That's actually our strategy. Because there's an alternative, and it's this. You know, if you just set out to build Rosie the robot, you probably won't make it. And this is actually super depressing to me, because I've been an Asimo fanboy since literally it was on, you know, Beyond 2000 in 1986, and I feel really bad, like, naming all the robots I've been rooting for that are now gone. But it's just sort of like a fact in this industry is that the technology is like perpetually 20 years away, and there's another example of this. This is kind of a common example, so I'll just skip through it really quick. But basically, this computer from Xerox, it's kind of famous. It's a Xerox Star, successor to the Alto. It was 20 years ahead of its time, and Xerox was a massive company back then. They invested millions of dollars and spent more than 10 years basically creating this modern computer. You can see there's a mouse and a GUI, and all that stuff is like right there. This is amazing in that it has Ethernet, you know, it has a hard disk, it has like local area network, object-oriented programming language, it has a graphical user interface. This is 1980. And they had all of that stuff, and of course, you know, never sold any. This computer came out 4 years later, and if any of you have ever programmed this exact computer, I'm not talking about its successors, but the old 128K Mac, you'll realize it barely has enough memory to edit 1 page of text. There's no way to add memory to it. You can't add a hard disk. The network wasn't there.
Did it?
Yeah, well, okay, fine. If you're good with soldering, which I'm sure you are.
16 memory chips and clipping 1 resistor.
Okay, it doesn't sound so bad when you put it that way, but not very good, right? I mean, this was a toy, but it was also a huge success because it let people buy into sort of the future of computers. And, you know, along the way, because it was cheap and it sold a lot, it got a sequel and another sequel and another sequel, and next thing you know, there's the future of computing. And the Xerox Star is sort of this really cool historical footnote. So you know where I'm going with this. That's what we're trying to do. Basically, there's this top-down approach to running a robot company where you aim 20 years in the future and you build and build and build and build and build, and in 20 years you get shut down. Or maybe you ship the product. But we're trying to take the approach where we do little tiny incremental steps and basically release software every year and robots every 2 years. And we've just been doing that like clockwork since we got started. So this was our first product. And it was a little disappointing. I remember when I was really proud of this because, you know, one guy, basically me, designed the circuit board, wrote all the bootloader, you know, drivers, a lot of the low-level firmware, built test fixtures, got the FCC certification and all of that. And people were coming up to me and saying like, so after that Nito robot, you built a line follower? You know, and you know, Nito was 8 years old when we finally shipped that thing. Is that correct? 7 years? I don't know, you're the historian, but.
When you shipped Anki Drive?
No, sorry, when we shipped the XV11.
2010.
Yeah.
So it was 3 years.
Since I joined, no, sorry. But anyway, I'm just saying that the company had been building for a long time. And so anyway, this thing we had to launch 1 year after we closed funding. So it wasn't a big hardware effort, but outside the hardware team, we did so much work it was ridiculous because we had to hire, you know, robotics and software people, iOS and Android engineers. We had to create a supply chain and find vendors, get a factory, establish sales and distribution channels, develop our whole marketing strategy, and we had to build basically an entire company just to ship this one thing. And at the same time, the robotics challenges were real. It was a surprise to me, and I thought this was a line follower, but you know, these little cars run at 2 meters a second. And compared to Nito, like there's a lot of interesting localization and planning problems when you're running that fast. I mean, they really move. So then we built this, and this is closer to sort of like what we wanted to build. This robot, Cosmo, you know, we had built the company out, now we really wanted to build this mobile manipulator with computer vision and personality, which sounded really hard. It turned out to be even harder. And because it's supposed to be this social robot that literally makes eye contact with you and reads your expressions and knows your name and recognizes your face, it does all of these things. And is supposed to create some sort of like emotional connection with you by expressing its personality. I know this sounds totally cheesy, especially to an engineer like me, but that was really hard. And so we hired character designers who did what they do. They developed Cosmo's personality using storyboards, and then they came back to the software team and they told us, actually, you know what? It's hard to express emotions using XML files. We didn't know that, but you did. And so we used Maya, just like you're talking about. Yeah, for exactly the same reason. Basically, the character designers are like, if you really want to express an emotion, the subtlety is way more than you're realizing. It's not like linear interpolation from point A to point B over time X, which is what I thought emotion was. But instead they used Maya. And so And it basically really paid off. Like they have the ability in here to control like every little detail of like the motion of the eyes, the size, the expression, all of the facial expressions in synchronized with the treads and the lift and head and all of that stuff. And the sound, the audio track, all of these things are all synchronized together. And it actually kind of pays off unbelievably. During testing, we found that like people were actually getting really fooled by this. And I learned something interesting about social robots while I was working on this product, which is like people find patterns even if they're not there. When the robot screws up, and you guys know your robots always screw up, our robots always screw up. They do the wrong thing for the wrong reasons. They make the wrong choices. But yeah, people make up the story. And the more the robot emotes, the more convinced they are that the robot has this inner world and it basically has a reason. And so when it does something completely stupid like suicide off the table, they're convinced that it was for a reason. You can't talk them out of it. The robot really has feelings. And so this was just like really surprising. Maybe it shouldn't have been, but people really became sort of like connected to the robot. And then of course, it's also a mobile manipulator because, you know, emotions weren't hard enough. So, so basically, you know, it comes with these toy cubes, and it can pick them up, it can stack them, it can roll them, it can do all kinds of it can tap them, it can push them over, it can do all kinds of manipulation with them. And just like the Nito, it has to do it in a million different homes, in all kinds of different lighting conditions, on all kinds of different surfaces, which means like, you know, the treads are connected to the encoders, connected to the gyro, connected to the animation system, making 200 adjustments per second so that it can dock with these tiny little features on the cube within a millimeter, which is what it takes to successfully stack or do that. Oh yeah, and I guess I had to mention the vision team also had to have every camera calibrated to within a millimeter. So anyway, you can imagine a lot of technology had to go into this. And then there's the cost. And I could do a whole presentation on this because when I started, I was really naive about hardware. And I think you know, this right here is a $180 robot. It comes with like a charger not seen here, and like these cubes and this robot and all that stuff. And what do you think our CPU budget was in a $180 robot? $10. $2. $3. You guys are pretty close. So you know where I'm going with this. It's actually $4, so we've kind of splurged. And unfortunately, that $4 gets split 6 ways because there's a CPU in each one of these cubes, of course. And there's 3 CPUs in the robot. Like this CPU up here runs the network stack and Wi-Fi. This CPU up here runs the camera and streaming video and audio. You know, it's got to do motion JPEG compression. This CPU down here runs the battery charger and the motor controllers. And you might think, why 3 CPUs? Well, it's cheaper than 1. And the main reason is there's just no chip that has all the peripherals you need. So we have to mix and match. That's the cheapest way for us to get all of the peripherals in like one device. So, sorry, go ahead. Was it easier to distribute the software load as opposed to just have it on one CPU? No, of course not. No, it's much harder. No, we tried to divide them logically. I know I kind of breezed through it, but like I say, there's sort of like an audio-video processor in the middle that sort of had that task, and then this is more robotics and motors and gyros down at the bottom, and then there's like Wi-Fi and networking up on the top, but it didn't matter. There's still lots of like synchronization and messaging and just complexity. So. Oh yeah, go ahead.
So I own a Cosmo robot, and I noticed that if you disconnect it from the phone, then it kills it. Would I be naive in thinking that the brains of Cosmo are located inside the phone while the robot manipulator and the sensors are actually just, it's collecting, that's how it's mainly collecting data, it's sensing the phone, it's all processing it's on the phone?
No, you're exactly right. And so if you missed that, what he just said was, where's all the computer vision and behavior and AI running? And the answer is on the phone, because, you know, we need, I shouldn't say we need, the software team demands the luxury of gigabytes of RAM and storage to do all of their robotics stuff, and so we run it up on the phone. And what that means is, for customers, like if you disconnect the phone, the robot dies, which is actually kind of a terrible experience, and we had to do it because of the cost. So.